Welcome back, folks. Today we are going to be talking about solving polynomial equations. So to start off, we have to start thinking about what the process is for solving by factoring. Where does the zero product property come in, and how does it work with this? And the answer is, when we solve a quadratic by factoring, what we do is we have to set one side equal to 0. That way we know one of the two things multiplied together is equal to 0. That will be the same idea over here. Now let's go ahead and get started with an idea of how we factor basically, and then we'll go into a couple of new ideas. The first and easiest way we have is factoring out a greatest common factor. And to do this, we say, let's look at 6x squared and 10x. What do both of those have in common that can be factored out? Well, both terms are divisible by 2, and both terms are divisible by x. So we can divide by 2 and x, and what are we left with? We're left with 3x plus 5 is equal to 0. And then all we do is we set each of these individually equal to 0. So we say 2x will equal 0, and 3x plus 5 will equal 0. So that's how we would solve using the greatest common factor. Our answers would be x is equal to 0 and negative 5 over 3. What about factoring when a is equal to 1? Well, to do this, we make our ACB chart. We say, what are our factors of a times c, or 6, that add up to 5? We go through our list. We say, factors of 6 that add up to 5, that's going to be 2 and 3. Multiply to make 6, add together to make 5. And this allows us to say, because a is equal to 1, we can just use our shortcut and we say x plus 2 times x plus 3 is equal to 0. And then we split this up and solve. So we'd say x plus 2 is equal to 0, and x plus 3 is equal to 0. What about when a is not equal to 1? Well, we're going to do the same thing here. We're going to make our ACB chart. We're looking for factors of 2 times 3, or 6, that add up to 7. Once we get those, which are 6 and 1, 6 times 1 makes 6, but 6 plus 1 makes 7. We can't just use our shortcut this time, though. A is not equal to 1. So what we instead have to do is we have to say 2x, and we split up our middle term, plus 6x plus x plus 3 is equal to 0. And then we put some parentheses around, and we continue to factor. We pull out what we can from each of these terms. So this will be an x and a 2 that we can pull out, 2x. We're left with x plus 3. And then we pull out nothing, so we pull out 1. And then we continue to factor. We say these two inside terms, x plus 3, we can factor those out, and we're left with 2x plus 1 is equal to 0. Now we also looked at the difference of squares. And this one was a little bit more confusing, but first we have to figure out what the squares are here. 25 is just 5 squared, so we can say this whole first term is 5x squared minus, and 16 is 4 squared, and this is equal to 0. What we do now, we see we have two perfect squares here and no interior term. This means that we can factor this out to say that it's going to be 5x plus 4 and 5x minus 4 is equal to 0. Why does this work out? Well, if we were to FOIL this again, our two interior terms would cancel, our two x terms would cancel, we'd be left with 5x squared, and we'd get minus 4 squared. So these are the ways we've already looked at. Here's one that we sort of have seen, but in a different way. For this, we're going to factor by grouping. When we have 4 terms here, x cubed plus 2x squared minus 3x minus 6, what we can do is the same thing as our first steps with an ACB chart. We take our first two terms, we put them in parentheses, and we put our second two terms and put them in parentheses. This is the confusing bit, but from here it acts the same. We say, what can we pull out of these first two? Well, both of these have an x squared, so we'll pull out an x squared, and we're left with x plus 2. What about these other two terms? Well, we can pull a 3 out of those, and what are we left with? X plus 2 is equal to 0. Now this follows the same principle. We need to have these two interior terms, our x plus 2 and x plus 2, be equal to the same value. That way we can pull those out, and we're left with whatever we pulled out originally. So x squared minus 3 is equal to 0. And now all we're going to do is we're going to split this up like normal. We're going to say x plus 2 is equal to 0, and x squared plus or minus 3 is equal to 0. And then we just solve. So this becomes x is equal to minus 2. This becomes x squared is equal to 3. And our answer for this is not just the square root of 3, it's plus or minus the square root of 3. Remember, when we take the square root here, anytime we are the ones physically taking the square root, we have to remember our positive and our negative values. So that's a slightly new one. Now we have one that's entirely new. It's called the difference or the sum of cubes. And what this is if we look at these, we see we have a cubed plus b cubed. What does this become? Well, it becomes a plus b times a squared minus ab plus b squared. And you might be saying this is really confusing. This is where we use SOAP. So SOAP helps us remember what each of these different terms are, or what the different signs are. The way it goes is the S stands for, our first sign is the same. The second sign we're going to have as our opposite. And then our last sign is going to be AP, or it's always positive. So if we remember SOAP, all we need to remember is it goes A, then B, and then we multiply that to A squared. We combine the two terms, AB, and we have B squared. But if we look at this, our term is plus, we have A plus B, times A squared, so it's minus AB, and then our last sign is always positive, so it's plus B squared. What about with subtraction? Well, we're going to have the same first two terms. It's A, except for this time our sign is the same. So it's minus B times A squared. Our second sign is opposite, so it's going to be plus AB. And our last sign is always positive, plus B squared. So these are our two new formulas that we can use. Let's go ahead and use them to factor 8x cubed plus 27. For this, let's make sure we understand what everything cubed is. So 8 is 2 cubed. That means that our first term is going to be 2x cubed, and 27 is 3 cubed. What does this mean? This means that A is 2x and B is 3. So now using A as 2x and B as 3, we're adding these, so we're going to use the addition formula. So when we factor this, this is going to become 2x, or A, plus B times 2x squared minus 2x times 3 plus 3 squared. And from here we got to keep reducing. So this becomes 2x plus 3 times 4x squared minus 6x plus 9. And are we done at this point? It's a trick question. The answer is no. We still have an x squared minus 6x plus 9. So we have to factor out this term as well. So we're going to make our ACB chart. We're looking for factors of 4 times 9, or 36, that are going to add to minus 6. Let's go ahead and work through this, see what we find. Now we keep doing this, try as we might, but we won't find any factors of 36 that add up to negative 6. So now that we've proven that, this is our factored form. Right. Let's go ahead and do a couple of practice problems. Oh, here we have some hints to help you how you should do this. I'll do a couple of practice problems, and then you'll go ahead and do a couple of practice problems. So step 1, anytime you're solving a polynomial, is see if you can factor out a greatest common factor. If you can pull anything out, it'll make your life simpler. Next step is going to be see if you can continue to factor what is left. And if you can't, what you're going to do is you're going to use the quadratic formula. But this is if the quadratic can't be factored. Now let's go ahead and do a couple of practice problems here. First thing we got to do for this first problem is we need to make one side equal to 0. So we need to bring the 3x over the other side. And step 1 is going to be factor out a greatest common factor. Each of these terms has an x that can be pulled out, so we're left with 2x squared minus 5x minus 3 is equal to 0. Next step is to continue to factor what's left. So we're looking for, if we do our ACB, we're looking for factors of minus 6 that add up to 5. We do this, we see that 6 and negative 1 fit the bill. 6 times negative 1 gives us 6, but added together they make 5. So we're going to split up that middle term because our a value is not 1. So this becomes 2x squared plus 6x minus x minus 3 is equal to 0. And now we keep factoring. So we do x, and then what do we pull out of these first two terms here, and what do we pull out of these second? Well, the first terms, we can pull out a 2 and an x, and we're left with x plus 3. We pull out a minus 1 from the other terms, and we're left with x plus 3, and this is equal to 0. And from here, we just finish our factoring. So this becomes x times 2x minus 1 times x plus 3 is equal to 0. Now, even though we have three terms, all we're going to do is we're going to split this up 3 ways and solve each equation. So our first term is x is equal to 0. So that's one answer. Our next term is 2x minus 1 is equal to 0, or that's going to be x is equal to 1/2. And our third term, x plus 3 is equal to 0, tells us our last term is x is equal to negative 3. So these would be our 3 solutions to this equation. If we could put these all in and see if it makes sense. If we substitute in 0, both sides come out to 0. If we substitute in 1/2, we could solve that. And if we subbed in negative 3, we could solve that. Let's do this next one. We're going to have to move the 6x cubed over to the other side. So this becomes 3x to the 4th plus 12x squared minus 6x cubed is equal to 0. And this isn't in standard form, so let's go ahead and rewrite it in standard form. So this becomes 3x to the 4th minus 6x cubed plus 12x squared. Step 1, factor out a greatest common factor. So what can we pull out? We can pull out a 3, and each of these terms has an x squared. So we'll pull out a 3x squared, and what are we left with? We have x squared minus 2x plus 4 is equal to 0. Step 2, see if we can continue to factor. Do we have factors of 4 that add up to negative 2? Well, we could try 4 and negative 1, or 4 and 1, negative 4 and negative 1, 2 and 2, negative 2 and 2. None of those work. So that means that we're going to have to use the quadratic formula to do this. Let's see. For the quadratic formula, we'll get x is equal to negative b plus or minus the square root of b squared minus 4ac. Substituting in our values, so 4 times 1 times 4 all over 2a. So let's keep reducing this. This becomes positive 2 plus or minus the square root of 4 minus 16 over 2. Or 2 plus or minus the square root of negative 12 over 2. So what does this make our answers? Well, the square root of negative 12 is going to be 2I root 3. So this is 2 plus or minus 2I root 3 over 2. And now we just cancel these out. So two of our solutions are going to be 1 plus or minus I root 3. And our last two solutions, coming from down here, we'll get x is equal to 0. Because substitute this in, 3x squared is equal to 0. We get x is equal to 0. And we get x is equal to 1 plus or minus I root 3. Right, so that's the basics. Let's have you try some on your own this time. Starting off with this first problem. What are the solutions to this going to be? Step 1 of this is going to be factoring out what we can. Each of these terms is divisible by 3 as well as x squared. So let's pull out a 3x squared. What are we left with? We have 2x squared minus 9x minus 5 is equal to 0. Let's go ahead and do our ACB chart. So this is going to be factors of negative 10 adding up to negative 9. And that's going to be negative 10 and 1 multiply together to make negative 10, but add to make negative 9. So we'll split this up. We'll get 3x squared times 2x squared minus 10x plus x minus 5 is equal to 0. Now, we're going to make each of these into its own set of parentheses, so we can pull out what we can. We'll see we get 3x squared. We pull out a 2x. We're left with x minus 5 plus 1 times x minus 5, which is equal to 0. Or this becomes 3x squared times x minus 5 times 2x plus 1 is equal to 0. And from this, we set each of our terms individually equal to 0. 3x squared is equal to 0. X minus 5 is equal to 0. And 2x plus 1 is equal to 0. When we solve, we'll see that we get answers of x is equal to 0, x is equal to 5, and x is equal to negative 1/2. Again, we can substitute these back in, make sure that this makes sense. Right? What about problem 2? Let's go ahead and have you try to solve this. Step 1, we're going to pull out the greatest common factor. Each of these terms is divisible by 3 and x. So we'll factor out a 3x. What are we left with? X squared plus 5x plus 1 is equal to 0. Now we try to do our ACB chart. We're looking for factors of 1 that add up to 5. And nothing's going to work. So we're going to need to do the quadratic formula. We get x is equal to negative 5 plus or minus the square root of 5 squared, or 25, minus 4 all over 2 times 3, or 6. So this will be equal to negative 5 plus or minus the square root of 21 over 6. Now, can we factor anything out of 21? Can we reduce that? Well, let's see. 21 is divisible by 3. That gets us to 7, and 7 gets us to 1. So no, 21 cannot be reduced. Meaning that our answers are going to be x is equal to negative 5 over 6 plus or minus the square root of 21 over 6. And then from this first term, can't forget about that, we say 3x is equal to 0. Our last answer is going to be x is equal to 0. So our solution for the first one, x is equal to 0, 5, and negative 1/2. Our solution for the second one, 0 and negative 5 over 6, plus or minus the square root of 21 over 6. Now this last one we have is a little bit tricky, so let's reduce this first so that we can figure this out. All right, 8 is 2 cubed, so that means that this first term is 2x cubed, and we have minus 1. Now 1 cubed is the same thing as 1. So this is the same as saying 2x cubed minus 1 cubed is equal to 0. So we know then we're using our difference of cubes. We have a is equal to 2x and b is equal to 1. Go ahead and try to solve from here. So for this, we're going to need to use our difference of cubes. That means that we'll have 2x, same, SOAP, right? We use SOAP here. So our first sign is going to be the same. So it's 2x minus 1 times 2x squared. Our second sign is opposite, so it'll be plus 2x times 1. And then our third sign is always positive. So it'll be plus 1 squared. Or when we reduce this, this is 2x minus 1. Of course, this is equal to 0. So this is 2x minus 1 times 4x squared plus 2x plus 1 is equal to 0. Now let's see if we can factor 4x squared plus 2x plus 1. So we're looking for factors of 4 that add up to 2. Again, this isn't going to work. So we're going to need to use the quadratic formula for this squared part. We'll see that we get x is equal to negative 2 plus or minus the square root of 2 squared minus 4 times 1 all over 8. Or this will be negative 2 plus or minus the square root of 4 minus 16 over 8. So this will be negative 2 plus or minus, we have the square root of negative 12, which we said is the same thing as 2I root 3 over 8. And when we reduce this, we have negative 2 over 8, so that's negative 1 over 4, plus or minus 2I over 8 will become I over 8 root 3. So two of our solutions are 1/4 plus I over 8 root 3 and negative 1/4 minus I over 8 root 3. Our last one is going to come from 2x minus 1 is equal to 0. So our last one is going to be x is equal to 1/2. So these are our three solutions for this equation. We're going to skip over u substitution here, and we're going to go to solving by graphing. Here we have two different equations here. X cubed plus 5 is equal to 4x squared plus x. Let's go over the two different methods we can use to solve this. Our first method here is we graph both of these individually and see where they intersect. So method 1 is going to be graph both and then find their intersects. So let's go ahead and put these into our calculator and then we'll check their intersects. So here we are. We have both of these ready to graph. We're going to make sure that we get a good old zoom. We're going to go make sure we have a standard zoom there. And here we have our two graphs. Looks like we have two intersects here, but how do we figure out what these are? Well, to do that, we're going to have to go back into our calculate menu. You'll see if we, right above the trace button, we have that calc. So if we hit second trace, we'll get into this calculate menu. And you'll see the fifth item here is our intersect. It's where these two graphs intersect. So if we hit enter on that, this is what we're going to use. It'll ask us for the first curve and the second curve. You're okay to just press enter and enter. You want to make sure you have your two different curves. And next it'll ask you for a guess. So we're going to get pretty close here to what we think is correct. And this will be our intersect. So let's go ahead and write down all of what we have so far. We did a basic sketch of the graph. So our graph looks something like this and that. Our first point over here was the point x is equal to 1.099. Not 1.099, 1.094. So that one solution is x is equal to 1.094. The other solution is going to be, we're going to do this calculate the intersect again, except for this time, we're going to put our guess over near this other one. So we're pretty close there. This tells us that our second solution is x is equal to 1.163. So we get x is equal to 1.163 and x is equal to negative 1.094. So that's the first method we could use to solve by graphing. The second method would be get everything to one side and then find the zeros. Let's go ahead and try this method. So here we are. We've moved all of our equation to one side. We get x cubed minus 4x squared minus x plus 5 is equal to 0. We have that ready to graph here. Let's go ahead and graph this. This time, we go and we see that we have actually 3 solutions here. What this means is we missed another 0 doing this the old way. We had to zoom out a little bit more to see a third intersection point. Let's go ahead and see what that third 0 is, though. How do we find our zeros? Well, we go back into this calculate menu, and our second option here is 0. So it asks us for a left bound and right bound. We want the left side to be on the left of where we think the 0 is, and the right to be on the right, and then we just give it a guess. So our first solution here is negative 1.094, just like we had before. So let's sketch this. Let's put that down. Our graph looks something like this. Our first point over here, we had x is equal to negative 1.094. Let's find the rest of the zeros. Second one, we're going to hit calculate. We're going to go down to 0. We're going to put in our left and right bounds. And it turns out our second one, just like we saw before, 1.167 or 1.163. What about that last point? So that one is actually over here. We get 1.163, and our last point, if we try to find that one, gonna hit calculate, 0 again, and put in our left and right bounds, we get our guess. Our last answer is 3.931. So if you're asked to solve by graphing, you can use either of these methods. First step is to make sure that you're zoomed out enough to see all the interesting points, but you can use either of these when you do this. Anyways, folks, that's all we have for this lesson.